Welcome back, construction enthusiasts. Today, we are diving into Chapter 9, Reinforcement Takeoff Sheet, also known as the Bar Bending Schedule, or BBS. If you have ever wondered how engineers and quantity surveyors calculate the exact amount of steel needed for a building, this video is for you. Accurate rebar takeoff is critical. It saves money, reduces waste, and ensures that your concrete structures are safe and strong. Let us start with the basics. A rebar takeoff sheet is a structured table that records all the steel bars in a project. It includes bar number or mark, bar shape, dimensions in meters, labeled as A, B, and C, diameter in millimeters, spacing between bars, cutting length, number of bars, and finally, total length and total weight. One key formula every quantity surveyor uses is for the unit weight of steel. The formula is unit weight in kilograms per meter equals the diameter squared divided by 162. This formula comes from the density of steel, which is 7,850 kilograms per cubic meter. Here is the derivation. 1 meter of bar has a cross-sectional area of pi times the radius squared. Multiply that by the steel density, and you get the weight per meter. For example, if the diameter is 16 millimeters, the unit weight equals 16 squared divided by 162, which is approximately 1.58 kilograms per meter. Next, let us talk about the number of bars, especially for stirrups or evenly spaced bars. The formula is number of bars equals the total length of the element divided by the spacing, plus 1. The plus 1 ensures that we account for the very first bar at the start of the element. For instance, if a beam is 6 meters long and the stirrups are spaced every 200 millimeters, the number of bars equals 6 divided by 0.2, plus 1, which gives 31 stirrups. Then we have cutting length. The cutting length includes the actual length of the bar plus any hooks, bends, or laps. For example, a column bar might be 3 meters long, and each end has a hook of 0.15 meters. So, the total cutting length equals 3 plus 0.3, which is 3.3 meters. Similarly, the stirrup length formula is stirrup length equals 2 times A plus 2 times B plus the hooks, where A and B are the horizontal and vertical sides of the stirrup. This ensures you cut enough steel for each bent shape. Once we have the cutting length and the number of bars, we calculate total length and total weight. Total length equals cutting length multiplied by the number of bars. And finally, total weight equals total length multiplied by unit weight in kilograms per meter. Let us take a quick example. A 10 millimeter diameter stirrup has a cutting length of 1.7 meters, and we need 31 bars. The unit weight equals 10 squared divided by 162, which is approximately 0.617 kilograms per meter. Total length equals 1.7 multiplied by 31, which is 52.7 meters. Total weight equals 52.7 multiplied by 0.617, which is approximately 32.5 kilograms. Now, let us apply a real example for clarity. We have a reinforced concrete beam with a length between columns of 4,000 millimeters. The column size is 230 millimeters. The stirrups are spaced at 180 millimeters from center to center. The longitudinal reinforcement consists of 2 top bars of 10 millimeters in diameter, and 2 bottom bars of 20 millimeters in diameter. To calculate the number of stirrups, we use the formula. Number of bars equals the total length divided by spacing, plus 1. The total length of the beam in millimeters is 6,800 millimeters, divided by 180 millimeters, plus 1, which equals 47 stirrups. The cutting length of each stirrup is calculated as hook plus 4,000 millimeters, plus the column size, minus the concrete cover. This gives the exact length of steel to be cut for each stirrup. All these values are then recorded in the takeoff sheet, including bar mark, bar shape, diameter, spacing, cutting length, number of bars, total length, unit weight, and total weight, following the standard BBS format. And that is how rebar takeoff and bar bending schedule preparation works from start to finish, including a detailed example from a real beam. Don't forget to like, share, and subscribe for more construction and quantity surveying tutorials.